timelines. This is probably one of my favorite frameworks, and the reason for that is because with a timeline you get this aerial view of everything that's happening. So let's have a look at this. Let's start right here. So that is today. It'll be the beginning of year one. Now this whole segment would be year one itself. In other words, there's 365 days in between 0 and 1. So when we get to this point over here, this would be the end of year one. But at the same time, the end of year one is also the beginning of year two. So once we figured out what's happening within this segment, we can use this as a template to figure out what's happening at any segment of the timeline. So for example, if we're looking at 17, how do we interpret that? Well, how did you interpret the 1? 1 is the end of year 1, so therefore 17 is the end of year 17. But at the same time, 1 was also the beginning of year 2, so 17 would be the beginning of year 18. So once again, do you see how I'm using this segment here as a template for all these other future segments? So now let's carry on from t equals 17. So we said that this would be the end of year 17, which means the year that follows would be year 18. So when we get to 18, this would be the end of year 18, and you can see that right here, right, ladies and gentlemen? So if you get here, so if this whole thing is year 18, then this point over here represents the end of year 18, and therefore the beginning of year 19. So ladies and gentlemen, I can't emphasize this enough. On the exam, if the question is focusing in on some future point in time, your starting point is here. So use year one as your template, and then use that same template to determine what's happening in these future periods as well. Let's have a look at an example. Suppose that in 2 years, we expect to receive $50,000 per year for 3 years. The required rate of return is 7%, and we're asked to calculate what the future value of this investment stream will be at the end of year 6. So what this indicates is that the investor's horizon is 6 years. So clearly this is a time value problem, and you could see, right? So here's time, right? Here's time, and here's your value. So without missing a beat, here's my timeline. Let's see what's happening. We know that this totals into 6-year horizon. So what's the first thing that's going to happen? In 2 years, we're going to receive 50,000. So there's 2 years from now, 1 year, 2 year. We're going to be receiving 50,000 per year for 3 years. So here's the first 50, second 50, and the third 50. Perfect. Now what? They want to know what it's worth at t equals 6. So they want to know what this investment is worth right there. Okay, so to calculate our value at the end of year 6, we're going to do this in 2 steps. The first step is we need to find out what the cash flow stream is worth when it ends. And that's the thing with our valuation models. They tell you what that cash flow stream is worth either at the beginning of the cash flow stream or at the end of the cash flow stream. Now the reason I'm dwelling on this is because we don't want to know what the value is at the end of the cash flow stream, because you could see that there's a 2-year gap from the time where the cash flow stream ends to the time that we want to find the ending value. And this is why we need 2 steps. So the first step is right here. Let's find out what this 3-year annuity is worth. And the reason I'm stretching my segment all the way here is because if you look at it from this perspective, i.e. as of t equals 1, this would be regarded as an ordinary annuity. So you could see we have 3 payments, 1, 2, 3. But since the payment is occurring at the end, this would be regarded as an ordinary annuity. So let's find out what this ordinary annuity is worth at the end of its horizon. So here's step 1. We want to calculate what the annuity is worth at the end of its horizon, and the end of the annuity horizon is t equals 4, and that's why I have that little 4 there. So we use our annuity framework. So here's our annuity players right there, and we enter what we know. So 50,000 per year for 3 years, and the required rate of return is 7%. So then we just ask our calculator, what is this cash flow stream worth at the end of the stream, which is at t = 4? It'll be worth 167.45. And again, notice the structure here. We're treating this as an ordinary annuity. So we're pretending that the annuity stream or the annuity period starts from here and goes till there. And when you take that perspective, this would be regarded as an ordinary annuity, and therefore we don't have to make any adjustments to our calculator. We just enter these time value variables. Now here's the way the exam works, ladies and gentlemen. The decoy answers are usually interim answers, and this is an interim answer, meaning that it's not the final answer, it's just the answer for one of the stages. Because the CFA folks know that a lot of candidates will take the bait and think that this is the correct answer. It's not. They didn't ask you what the cash flow stream is worth at the end of t = 4. They asked you for what it's worth at the end of t = 6. Ladies and gentlemen, we have to remember the investor's horizon does not always coincide with the investment's horizon. The investment stops paying cash flows at t = 4, but the investor's horizon is at t = 6. So the question says, well, how much will it be worth when the investor is ready to cash out her entire account? So what we have to do now is we have to take this 160,000, which represents the value at this point in time, and then bring it forward 2 more periods. And that's exactly what we do in step 2. So in step 2, we want to find out the future value as of t = 6, so the value at the end of the investor's horizon. And just to reiterate, the value of the investment at t = 4 was 167.45, and as I indicated before, we just need to compound it 2 more periods to find out what it's worth over there. So within this context, so in this context right here, the 167.45 is actually our present value. So do you see the difference in the stages? We have this 160 over here. That's what that dot is. Now, if you're looking at step 1, that 160 is the future value. But if you're looking at step 2, ladies and gentlemen, within the context of step 2, that 160 is the beginning value. And that's exactly what we're doing here. So that 160, which was the future value in step 1, now it's the present value in step 2. Because now the 160 is acting as our starting point, not ending point. And then now we just compounded 2 periods at 7%. So by the time you get to t = 6, that 160 will be worth 184.037. So this would be our correct answer.